What is happening with Comet's 3I Atlas, R2 SWAN, and the new comet discovery, Borisov C 2025 V1? There are numerous unanswered questions and anomalies that beg for explanation. For example, with regard to 3I Atlas, why was NASA so timid with their recent press release? Why the dramatic increase in brightness of 3I Atlas as it reached perihelion? How are we to interpret the behavior of the outgassing of 3I Atlas, wherein we see plumes of gas ejected tens of thousands of kilometers away from the nucleus of the celestial body? And why are we seeing such great images from amateur astrophotography which rival or surpass what we've seen from NASA's imagery? We'll address some of these questions in this episode of Squaring the Circle. Hello everyone, here I am back at the recording studio after a eventful tour of the Azores Islands, and accompanying me on that tour and collecting some great imagery, video footage and drone footage is my friend and colleague John Arthur. Are you here, John?
Howdy, Randall.
Howdy, John. Well, it's good to see you this way, although it was good to see you certainly during that several weeks exploring four, not just one, but four of the 9 islands in the Azores. And we're going to be having a lot to report on that in the next few weeks. So people will have that to look forward to. We were there ostensibly looking for evidence that would suggest a consistency, not a proof, but a consistency with Plato's account in his 2 dialogues, Timaeus and Critias. But here today, we want to catch up a little bit on some of the cometary activity that's been going on in the last 3 or 4 weeks. So I think we should just dive right into it. Well, I'd like to talk about this new comet SWAN, but before we do, why don't we jump back a little bit to 3I Atlas and address a few of the questions. Now, we're not going to have time to address all of the interesting questions and anomalies that have come up with regards to SWAN in this episode, but let's at least look at some of them. So I think you've compiled a few things for us, John.
I do have quite a few images from NASA and then some from non-NASA sources. So when you and I were prepping this show, we were kind of looking back at some of the images that we had been starting off with. You remember this one?
Oh, yeah.
This was one of the first ones.
Right.
That we saw. This is our first introduction back in July to 3I Atlas. And so I just want to kind of lay this out. I think it's important to see where we came from and why it's kind of interesting that the amateur astrophotography scene is doing as well or better than NASA. So you'll remember this. This is probably the most famous to date image from Hubble. And this is from, again, July 21st. So who could forget the James Webb Telescope, which is this is in August, just walking through the timeline. And this is something that a lot of people have expressed some disappointment in NASA's response, because this is old stuff. This is from Sphere X. Remember, we were looking at the Sphere X and the spectrograph images coming in from Sphere X, again in August. Now, we've been waiting for Psyche. We've been waiting for Psyche to come in. I'll go ahead and download this. This is all available on NASA's website. The link will be in the description below. But you can see September 8th, September 9th. It's crossing the sky or through Psyche's field of view. And if you look down here, we'll pull over to here. This is our 13,000 kilometer legend, if you will, our scale.
Which comprises 50 arc seconds there of the sky. Okay.
Correct. And so that's what Psyche was able to see. Psyche, if you remember, we covered this, is a satellite that's en route with a payload to the asteroid Psyche. Really cool mission. Looking forward to the results from that. Then, of course, we have this image from Stereo. And this is a stack of exposures, and they colorized it so that we would see the it'd be visually distinctive from all of the other images. But again, look at what we're not seeing. Anything more than just a coma.
Right.
This has led a lot of people to express some frustration or even question what NASA is or isn't putting out.
Okay, so this is, stacked images from September 11th through 25th. So this was before perihelion.
Correct. Correct. And it's just now available to us. Now, this is from Lucy. Remember, we talked about Lucy, another payload on its way to something else. But you can see this is from Lori Panochromatic, black or white imager on the Lucy spacecraft. This is again.
Looks to me like there's a little bit more brightening on the right side of the thing.
I believe so. So this image spans about 11 arc minutes of sky.
Right there, it says its tail, a smudge of gas flowing to the right of the comet.
Correct.
11 arc minutes of sky. Okay, so that's 11 arc minutes. So, and the last one we saw was 50 seconds. So 11 arc minutes would then be 660 seconds, and we divide that by 50. So this is showing roughly 13 times greater width of the sky image than the previous one, just to help people get perspective.
For scale, yeah.
For scale, yeah.
And then we have the images from Punch. Whoops. And again, note what we're seeing or what we're not seeing. We don't have a good definition on this. And this is, again, taken from September 20th through October 3rd. So coming closer to perihelion. We're finally getting a chance to see the Punch images. When you and I left, or we were getting ready to leave for the Azores in this last month of November, this wasn't available to my knowledge. We were still waiting for these images. Okay. And here we have Maven, which is providing us with some really interesting understanding of 3i Atlas. It's actually measuring the hydrogen signatures via the UV spectrum from Mars. You can see the interplanetary hydrogen, and then you can see 3i Atlas's off-gassing of hydrogen. So for those of you on audio, my apologies. You'll have to go over to the YouTube or the Rumble to see this, or check out the links in the description, and you should be able to pick this up. But again, it's very interesting. But this was the image that I think culminated everyone's complaint about NASA's their press release and everything to date, because I think everyone was very much expecting something very amazing and wowing. The Mars Reconnaissance Orbiter with the HiRISE in the payload, the high resolution image science experiment HiRISE camera captured this image. And if you zoom way into this, you can see at the finest point. I'm going to kind of move over here. Right around here is the, again, it might be hard to see, but right there you can kind of see the center, the nucleus, just barely. It's just a couple of pixels. And again, this doesn't even give us enough data to really be certain of even the the diameter of the nucleus. I mean, this is not a lot of data. And this is the single closest, highest resolution image that we have. It was taken 19 million miles away, and it still is not a whole lot of data. So 30 million kilometers for those of you in Europe.
Well, John, I would like to give a shout out to our sponsor, Ground News, which we have been finding to be a very effective tool. I was very appreciative of having that tool accessible when we were in the Azores, and I needed to find out what's going on out there in the rest of the world, what's going on with some of the topical matters that we have been discussing. And I see that you've pulled up right there, you're from Ground News. NASA unveils close-up pictures of the comet popping by from another star. What did you put in the search engine for that?
Well, for this, I just typed in 3i Atlas.
3i Atlas, and you got a lot of options, didn't you?
And I got plenty of options, and I could look at each one of these sorted by bias distribution, left, right, center, and you can have a bias comparison. It's pretty clean, pretty fast. I can kind of see where the political priors are for whoever's writing the articles.
And when I first heard about SWAN, I went into Ground News, put in Comet SWAN, and what I came up with was a comet tracker. Very interesting. How to find comets, Lemon and SWAN, on Saturday. Now, this is going back, a month, but I was able to use Ground News very effectively to get right into a whole list of available sources that gave me information about both Comet SWAN and Comet Lemon. So I found that the fact also that they will then give the links that allow you to go back to the original papers, I find very useful. So this is for me like a very effective shortcut that I'm able to use when I'm doing research. And I'm getting more and more in the habit of using Ground News as my first stop when I'm researching a topic, whether it's current events, whether it's foreign policy, whether it's economics, whether it's a scientific, all of things which I'm interested in to some degree or another. And this is really helping me to sort these out in a coherent manner, get to where I need to find the information that I'm looking for. If I wasn't finding this particularly useful and valuable to my own work and research, I would have not agreed to a sponsorship. But it was because I was already using them and thinking this is going to be a very effective tool in our toolbox that I readily agreed and said, absolutely, I will promote Ground News because it's really doing what they promised it was going to do. If you use the link on the screen or the code shown below or up there or over there or wherever it happens to be on the screen, you're going to save 40% on the Vantage plan for Ground News. And you'll be paying a mere $5 a month for this extremely valuable service. It's the one I use. And in addition to all of that, by subscribing to Ground News, you'll be supporting our work here at Squaring the Circle. So now back to the show.
So also they put the Perseverance rover's camera on this. And again, let me see if I can make that a little bit bigger. You can barely see it. So the Perseverance was never made to do astrophotography. It was meant to do stuff mostly on the planet. So this is kind of everything that we have. Because this is from Soho. This is between the 15th and the 26th. And you can kind of see this brightening of the image. This is during that passage during perihelion when it's opposite the sun from us. And so SOHO has a central disk blocking out the sun, and it's pointed at the sun. So, and this is just off on the side. And this is one of the places where we came to the this is one of the photos that we came to the realization that actually 3i Atlas got significantly brighter than we expected. 4 times brighter than we would have imagined if we compared to the brightest comet that as it passed perihelion. So it's significantly brighter. So all of those images are from NASA. Now, this is where the criticism from NASA really kind of, or against, pointed towards NASA comes in. This is an amateur photo taken from someone's personal telescope. And ZWO is the company. So this is from their Twitter or X account rather, and link in the description, of course, as always. Go give them some love. And the Ben Friedrich actually captured this. So less cropped in version. And that's what they took the image with. For those of you on audio, this is not a observatory-sized a telescope. It is definitely a professional tool. It is a large telescope, but it is something that you could easily put in the trunk of your car. Your tripod and everything, you could put this in the trunk of your car. So let's just look back at that image one more time.
And the green outgassing would suggest diatomic carbon.
Correct.
Now, diatomic carbon, just for explanation, is simply 2 carbon atoms bound together.
Correct.
And that's what appears to be outgassing here.
And what's interesting about some of these images, and we're going to get into it a little bit, what NASA did not seem to want to comment on in their press release, which I find to be a shame, is the very, very interesting set of anomalies. They mentioned anomalies, but they didn't go into any detail on some of these interesting jets that are off-gassing. Any of the fact that this became 4 times brighter than we could have possibly expected it to during its perihelion passage. These are things that I think it would have been nice if NASA had actually deigned to speak on it, but instead it was a very vanilla, just kind of glossy overview, things that we had already kind of known from the media coverage and things that amateur astronomers like Ben Friedrich had been able to capture and see a lot of, which is kind of sad.
Well, it makes you kind of wonder, are we getting the best bang for the buck from NASA? Now, NASA is one of the few government agencies that I provisionally support. They've had their better days and their worst days. And, you know, as a young fellow growing up, I was quite enamored with the activity of NASA and what they were doing back then in the heyday in the 60s and early 70s. But it's been a mixed bag since then, particularly with the 2 space shuttle disasters that really set NASA back. And it's, you know, easy to get into the political priorities of our government when NASA is continually being deprived of funds, and other favored nations and countries and things are now the recipients of funds that should be staying here to help America and move American science forward, but that's another discussion. So this it does raise a question, though. Yeah, I mean, that we're seeing actually what appear to be better imagery from the amateur astronomical community.
And then we have no explanation of phenomena like this.
Yeah, look at that.
This was from Michael Buckner and Frank Niebling, if I'm pronouncing those correctly, those German.
If I
German
had to
sounding
guess, I
names.
would say Buchner.
Buchner.
Buchner. But hey,
Okay.
I could be wrong.
And then Frank Niebling.
Niebling, I think I would go with that. Yeah.
So these are interesting, and Avi Loeb, among other people, have taken some of these images and they've drawn these vectors.
Yeah. Okay.
So you have up to you have 5 here in this image, but 7 different apparent jets coming off of 3I Atlas post perihelion.
Mm-hmm.
What's wild about these is we're talking this is massive 23,000 kilometers long, some of these jets. So how is it that we have these what appear to be somewhat discrete jets coming off of 3I Atlas? And some of them are, so if it says Sol at 296 degree, it has an arrow pointing this way, some pointing away from the sun, some pointing towards the sun. Avi Loeb thinks this is a techno signature, or is suggesting that it might be a techno signature. I don't want to speak for him. That this is somehow an alien craft in motion here, but it's not common to see tens of thousands of kilometer jets coming off of these things, off of comets. And in fact, we're talking about potential burn rate estimated of up to 13% of its mass to be able to accomplish these plumes that are this long.
Just for perspective on that plume there that you're looking at, the 2 longer ones, those are roughly double the diameter of the Earth. Roughly double. About 14,000 miles is about double the diameter of the Earth. So you could fit in that between the dark mass that represents the coma and the outer fringe of that plume, you could fit 2 entire Earth diameters in there. So that's a long plume.
And up until now, we've believed this object to be tumbling at a 16-hour rotation rate. 16.16 is the perceived or expected rotation rate. So how is it that we have these plumes? They would have had to have been there's one of three options. A, we're making some fundamental miscalculation. 1. 2, these plumes shot out at incredible speeds. Or it's not rotating, or it's rotating and it's ejecting these out in a timed pattern, which that would be a techno signature.
Now, if it was rotating, one would not expect to see the linear
plumes, but
geometry
rather
of these plumes.
a coma, just a dusty coma. Not.
Yeah.
I'm hesitant to call these organized, but I will say they're directional.
Directional, sure. I mean, that looks pretty evident from the image here.
So if they're directional, the next question is are they organized, or what was the mechanism that ejected these plumes of gas? Some people saying as much as, some estimates, Avi Loeb being one of them, 13% of the mass, expected mass, jetted off here in this moment. Is 3I Atlas about to break apart? Is 3I Atlas doing a thruster maneuver? Don't know. And what's disappointing is I do wish NASA had addressed this. This is really interesting. This is really fascinating behavior on the part of an interstellar object. But I think there's a little bit of a hesitancy to do that for fear of stoking, conversations that there aren't any answers for.
Mm-hmm. Yeah, that's the dance that you have to do with something like this. You have to kind of find that middle ground between skepticism on one end, because way too many people are all ready to make outrageous claims based upon flimsy data, or seeing something that's not fully explainable, but doesn't immediately then lead to the most exotic and outrageous of explanations. And then on the other hand, being so overly skeptical that you're not considering, that you're not willing to consider that some of the more outrageous ideas. So that's the dance we have to do in science, I believe, that we have to find that pivotal point, that balance point between skepticism and gullibility.
100%. 100%. And so one of the things that a lot of folks have, including Avilod, have come out and said that they wish that we had, or that had been addressed by NASA. And I would love to see what some of these minds think is the rapid brightening, which we've mentioned, but again, this will be linked in the description below for the audience to pick up. But this is from Qixing Zhang and Carl Batams. But effectively, after looking at several of the satellites that are in our atmosphere and not, specifically SOHO and Stereo, we could see that during its perihelion passage, this thing got bright, like much brighter than we expected. And it's also significantly bluer than the sun. So it was dark red when we first saw it. It looked like a Class D asteroid, which is a darker red color.
Mm-hmm.
During its perihelion passage, it turned from more green to more blue. And now it's kind of this green-blue color coming out. So that tells us maybe something about the chemical composition. But what we don't understand is how it surpassed expectations on brightness.
Mm-hmm.
And sometimes you have to be okay with saying, I don't know.
Well, sometimes you have no alternative than to say, I don't know.
I don't know. So for all the researchers who want to drop a comment on your thoughts on this, the only thing I can imagine is that we're looking at a ferocious amount of outgassing.
Mm-hmm.
So in their conclusion, they say, we presented observations of interstellar Comet 3I Atlas in solar coronagraphic and heliospheric imagery from Stereo, Secchi and Soho, Lasco, and Goes and CCOR instruments as the comet approached perihelion while near superior conjunction from the Earth. We performed image stacking and photometry with these data and obtained the following results. The comet appears extended in a stack of the frames from the CCOR1 with an apparent, 4 minute in diameter. There we go. I'm sorry, guys. I got a migraine. I'm having a hard time reading the screen. The comet rapidly brightened on its final approach towards perihelion over 2025, September through October, at heliocentric distance of around
radius less than or approximately equal to 2 astronomical units.
Yep. So the comet appears distinctly bluer than the sun, in contrast to earlier observations showing the comet's dust to be red, suggesting that gas emissions likely from diatomic carbon and possibly nickel and 2 hydrogen off gas contributes to a sizable fraction of the overall visible brightness. So it tells us something about the Constitution. What we don't know exactly is, and what's defied the expectations, is just how bright it got. Interesting.
So just you mentioned the term superior conjunction. Let's just clarify that a superior conjunction would be, in this case, the object is aligned with the Earth on the opposite side of the sun. If it was on the near side of the sun, it would be an inferior conjunction, but a superior conjunction means it's aligned with the Earth. So you'd have an alignment Earth, Sun, at 3i Atlas. And interestingly, remember we talked about the coronal mass ejection, whose timing seemed very coincidental with the with Atlas's 3
superior conjunction
during that superior conjunction. Yeah,
and at that time we had also attracted a small body. It's they were calling it a second moon, all in that one motion, which is very interesting. That we had a conjunction of this small moon, the small satellite, temporary satellite, the moon, 3i Atlas, and the sun. Very, very interesting. And of course, the sun reacted. Apparently, it appears to have been reacting to 3i Atlas. And some people in the comment section were very skeptical. They said, well, of course, you have lots of solar activity. We're right in the middle of a solar maximum. But that's kind of our point, is that there are lots of events occurring right now. And the fact that you see right at the moment of the conjunction, the question is not do these objects cause all CMEs? The question is are CMEs, is volcanism, are some of these conjunctions, is there a connection? Are all of these somewhat interrelated? Is there some effect they have on each other?
Clearly, I think the temporal correlation of these events is noteworthy.
It should be brought up.
I mean, we don't know what it means really at this point. We don't have enough data, but it's certainly a noteworthy correlation that should not be dismissed because, well, this was a period of heightened solar activity. True, I'll agree with that. But that does in no way diminish the significance of the correspondence.
Correct. And so we should be willing to consider some of these alignments and some of the interesting happenstances, if you will, as they occur. Now, on that note, someone was recently making a video on this. Stephen Burns was referencing SWAN, and specifically, he had this pincher maneuver video that he came out with. And by the way, Stefan, we saw your comment. We'd love to actually do a swap cast sometime. But you kind of have this faux conjunction going on right here with Earth and 3i Atlas. And we'll get to K1 Atlas in a little bit. We'll talk about that because that's an interesting historical note, what's happening with K1. But left it in here just so we could see. But SWAN, R2 SWAN, has gotten a lot of attention because it's recently, a lot like 3i Atlas, started to apparently emit a ton of C2. It's become very green. And it's developed an anti-tail, which is fascinating. For those of you who don't know, Astronomer's Telegram, the Astronomer's Telegram, this is a place where a lot of folks who are their eyes are peeled on the skies. They can check in here. But something that folks have been noting is that just like 3i Atlas, R2 SWAN has developed an anti-tail. which is interesting. In fact, I've got an image right here. So again, all of the links are going to be below for you to look this up. So you've got the tail going away from the sun. And then you have this very mild plume headed towards the sun. So R2 SWAN's another long period comet. And the fact that whatever it's ejecting is ejecting fast enough that it's overcoming the solar wind. And why do tails normally point away from the sun, Randall?
Well, that's because of the very fine material of the tail and actually being blown away by the solar wind, the heliospheric wind emanating outwards from the sun will actually move that stuff in the direction away. I think we did talk about this, that's why you're always going to see the tail of the comet pointing away from the sun. So an anti-tail is going to be pointing towards the sun.
And so you've got a tail pointing away here and towards here.
Towards, yeah.
And this
again,
is from
notice the graph at the bottom, 10 minutes of arc there for
those who are watching on YouTube or Rumble.
Yeah.
So this comes from Kumagaya Kimura on X. Want to make sure I attribute that accordingly. But that is interesting that we have two comets that are developing anti-tails. And by the way, anti-tails are not unheard of. They're a phenomenon that does happen, but they're unusual. They're highly unusual. Some people will say that it's never, if you're watching YouTube, there's a lot of schlock on YouTube that says, this has never happened. This is so unusual. It's very unusual, but it's not unheard of. It's just unusual. But this is where I say maybe 3i Atlas, maybe we're seeing the first part of a breakup event. Because what's happening with R2 SWAN?
It appears to be breaking up, which is pretty much part of the life cycle of a comet. I think at one point we talked about, I think I referred to the 5 phases of the cometary lifespan, and one of those, number 4, is the breakup of the nucleus. And there's many examples now of, Schwarzman-Wachmann, Comet West, Comet Linear, others that have been seen to break up and disintegrate. Comet Shoemaker-Levy 9, a big example from the from back in the 90s. So that was what I was calling in the 5 stages of the life cycle of a comet. The 4th stage was the disintegration, which includes the vaporization of an icy matrix, and then formation of meteor streams, dust streams after successive orbits. So that's what appears to be happening now with Comet SWAN. And then what eventually will happen is that material will disintegrate into fine dust. It will be a more macro scale and plummet into planets or satellites, or most likely it's going to be swallowed up by the sun at some point.
As we see happening with K1 Atlas right now, which we've been talking about for 3 months now. We've been mentioning K1 Atlas, but what we didn't know is how far down the cycle it is. And if you see on the screen here, again, if you're on audio, links in the description, you can see 4 distinct pieces of K1. And what's so interesting about Schwarzman-Wachmann or Levy 9 or K1 Atlas is that they provide really, really interesting glimpses into what can happen at the end of a life cycle of a body like this. And just imagine one of these hitting the moon or the Earth.
It seriously complicates the effects of an impact event, if it's a multi-impact event as opposed to just a singular encounter. And that, I think, is, what I believe we're probably looking at in terms of the Younger Dryas events, is a multi-impact event. And, of course, we'll certainly have more to say about that coming up.
Absolutely. And we got some fun stuff in the pipeline for that. And it's going to be interesting. But I think one of the coolest things about one of the most interesting developments with 3i Atlas is how many people you see who are ultimately just all on their own, providing incredible images that NASA, for some reason, is not providing, or institutionally they're not set up to do it. I don't know why. This is Chuck's Astrophotography. And you and I were talking about this beforehand. I kind of wanted to show, because one of the coolest images of 3i Atlas, this guy was filming some live, and then he also put someone else's up. I couldn't trace down the origin for this.
The Comet, I captured 3i Atlas yesterday, and Pete worked on it, and this is what he came up with. Let me show you this.
This is the color grade in the edit that he got.
This is pretty crazy.
Final product in edit.
We need to alert the media, because this has got to be the craziest picture of 3i Atlas I've seen yet.
Look at that. And there you have those jets that Avi Loeb's talking about. That's intense. And I guess my question is, why are amateur astronomers, and I don't use that term as a pejorative in any sense,
Right.
how is it that they're outpacing NASA, at least on what's being released?
That is pretty extraordinary. Something wild going on there.
Yeah.
We've got a new comet discovered by the same amateur astronomer, and you figured out, you got his first name pronunciation for us.
Gennady Borisov.
Okay.
Or Gennady. I think it's more of a Gennady.
I would,
because he's Russian.
Gennady Borisov. So Borisov is actually Croatian, right?
I'd have to look it up, but
I think that's what we saw.
Slavic,
I think
yes.
Slavic. Okay, so he has discovered another comet, which is now bears his name, not to be confused with interstellar object Borisov, that
2i Borisov.
2i, that was the predecessor to 3i Atlas.
And that's a common question we get in the comment sections. We've seen people ask, where did they come up with the names? Oumuamua, Borisov. Well, Oumuamua was named by the Hawaiians at the Hawaiian location where they first discovered the satellite network and telescope network, that they actually discovered that. But Borisov is named after Gennady Borisov, the discoverer. And 3i Atlas is named after the Atlas installation that discovered
Yes.
it. So just know that these names are, sometimes there are multiple Atlases, there are multiple Borisovs, there are multiple,
Right.
Swans.
And they're usually going to be preceded by their year of discovery and a code letter and a number that indicates their numerological sequence of discovery. So V1, I don't know what the V stands for in this case. V1 would be C 2025 V1 Borisov is the new one. It was first spotted on November 2nd. Actually, I said Croatian. I was wrong. He was Crimean. But let's emphasize he was an amateur, not a professional astronomer. Now, what's interesting about this comet is it sort of seems borderline between an intrasolar system comet and an interstellar comet, right? It's already made its perigee passage on November 11th. So today is the 26th. So, yeah, less than 2 weeks ago, it made its perigee passage at 0.689 astronomical units. So I think that works out to be, since an astronomical unit, again, is 93 million miles, that times 0.689 puts it at, about 64 million, about 64 million miles during its perihelion. No, that was at its perigee. At its perihelion, it was 0.463. So that would have been less than half of the 93 million miles to the sun. So 93 million would then have been times 0.463. That would have put it at about, 43 million miles from the sun. And that was on November 16th. So it made its perihelion, closest passage to the sun, on November 16th. Now, here's, to me, where it gets interesting. It's eccentricity.
Just so that they can see.
Yeah, there we go. Yeah, there you got it up. So a couple of things happening there. The eccentricity is estimated to be around about 1.0000096 or 95. I'll say that again, 1.0095. Okay, that puts it almost as a hyperbolic orbit. Eccentricity of 0 is a circle. And the closer you get to 1, the more eccentric that orbit will become. So when you look at this, let's see, let's define where is the orbit in this one. Okay, it's the lavender or purple.
The lavender, correct.
Lavender, okay. Yes. So it's highly eccentric, meaning it would be a very long period to complete one orbit. It's also highly inclined to the plane of the ecliptic. So unlike 3I Atlas, which is within 5 degrees of the plane of the ecliptic or the orbital plane of the planets, V1 Borisov is highly inclined. Let's see if I can find the actual inclination here. I know it was somewhere around 114 to 115.
It's 113.
113. Okay, so, and it's in a retrograde orbit, meaning it's moving in the opposite direction of everything else. But so let's picture this. If you have the plane of the ecliptic being a flat plane, and I begin to tilt the orbit of an object, another orbiting object, actually, you can see if I get to 90 degrees, I'm perpendicular to the plane of the ecliptic. If I continue on for another, 113 degrees, you can see there we're actually, this is where it becomes retrograde, right there. You see. So now we're at this high angle of inclination to the plane of the ecliptic, and which suggests it is not an origination in anywhere near the Kuiper disk. It has to be Oort cloud if it's within the solar system. And the eccentricity is such that it looks like it has a return period. And I was looking for the estimated orbital period. And let's see. Okay, yeah. An inclination of around 112 to 113 degrees on a retrograde path. Let's see, mid-November would have been at its brightest and best seen before sunrise in Virgo with your larger amateur telescopes. So it was not really one that you could go out and prominently look at with the naked eye. Let's see, it has a condensed nuclei with little obvious dust structure at this point. Avi Loeb commented with respect to V1 Borisov that similar to 3i Atlas 2025 C/2025 V1 Borisov does not display a clear cometary tail.
Which would suggest either its composition is not low in volatiles, or it hasn't activated yet.
Right.
But it's awfully close to have not activated.
So the lack of a clear cometary tail and the extreme orbital eccentricity match what sky trackers are plotting and help frame the label of nearly interstellar that appeared in a lot of the headlines, nearly interstellar. However, the various reports are that the weight of the evidence still supports the idea that it is part of our solar system and not an interloper from beyond. So, as usual, there's always a lot of speculation, conspiratorial stuff. It's always best in science to avoid that, but not necessarily altogether, because sometimes the bizarre aspects of things, the anomalies, the outliers turn out to be the actual case. But usually it's going to be a more prosaic explanation. And as we've discussed here in these episodes regarding 3i Atlas, I mean, this is an interstellar visitor that's unlike anything we've seen before. And we shouldn't necessarily be super surprised that something coming from an entirely different solar system in an entirely different part of the galaxy, there's no reason to expect that it's going to be identical or very similar to objects that we have become familiar with on our own home cosmic turf. So beyond, here's a quote from, was published in Reuters back in, well, this is way back with the first detection of 3i Atlas, admitting we don't know very much. And there are efforts underway to try to observe the object. Now, the point I think here is we're getting a bunch of data that haven't really had the chance to analyze yet or connect the dots yet. And it'll probably take years before that's done. So, as I think most astronomers are going to agree that Borisov V1 started out in the Oort cloud. Now, I should perhaps just share this image we've already looked at, but just to let people who haven't seen that episode, I will share this image now. All right, we shared this graphic here in an earlier episode, and it's a really great one as far as depicting the full scope and scale of the solar system, which includes the massive reservoir of comets. This is from starwalk.space/gallery/images. They've got some great images up there. Go check it out. But of looking at all of the images, this was my favorite. It shows, you can see here, the solar system, the planetary realm, right here at the center of this whole complex, and this is where the planets orbit. And then you can see moving outwards within that plane is the Kuiper disk, and then it phases into the Oort cloud. So if an object, a comet, is introduced into the planetary realm from the Kuiper disk, it's going to be laying close to the plane of the ecliptic, right, the orbital plane of the planets. If we see one coming in at a high angular inclination to the plane of the ecliptic, it's not coming from the Kuiper disk. It's coming from somewhere out here in the Oort cloud. So we saw that it was actually 113 degrees, which puts it into this retrograde or backwards orbit. And I think this will help clarify to people one of the differences between short period comets, which originate from the Kuiper disk, and the long period comets, which originate from the Oort cloud. And you can see here that, if you're looking at a comet coming in from the inner zone of the Kuiper disk, obviously it's much, much, much closer to the zone of the planets, and therefore it's going to have a much more less eccentric elliptical orbit than one coming from way out here that's going to have a very long period because it's essentially coming in to the sun and then going back out some undesignated distance to the cloud itself. So hopefully that will help to clarify that relationship between short period and long period comets. And the long period comets are going to be their elliptical orbits are going to be much flatter, that is eccentric, symbolized by the letter E, compared to the Kuiper disks, which are going to have closer to circular. Now again, zero eccentricity is circular, and we don't find in nature any perfect circle, certainly not in orbital phenomena. But what we do find is varying degrees of eccentricity, which is, the flattening of the circle. So if you start with a circle with zero eccentricity and then you flatten it, it gets more and more eccentric. And essentially what's happening there is you've got one focal point, which is coincides with the center of a circle. And as you flatten that, one center or focal point becomes two focal points. And the farther apart those move, the flatter the ellipse becomes, right? And that's what we're seeing here. When we talk about eccentricity, we're talking about the shape of that ellipse. The more eccentric, the flatter it's going to be. The less eccentric, the rounder it's going to be. Okay, so like it says here, as the arc length grows, E, the eccentricity, often slides back toward one, pointing to a bound or marginally bound long-period comet. The steep retrograde inclination near 113 degrees also matches the high latitude injections seen for many Oort cloud entries rather than an origin in the planetary plane. It goes on to say that the subdued tail isn't especially anomalous because comets can be dust poor. They can be dominated by carbon monoxide or carbon dioxide outgassing, or just depending on the angle, it might not be suitable for observing the outgassing tail. So what they're looking for is the spectra and higher signal to noise imaging. So that's what's happening with Borisov right now. Now, this is going back here a week or so after first detection of the object. So there may be a little bit more recent updates on Borisov that I haven't had a chance yet to really dive into since we've returned from this expedition that we were on. Okay, so one of the comments is here, it supports, is consistent with what we would expect from a long period comet. And it's moving at a high rate of speed towards the sun, made its perihelion passage, and I think it was useful to discuss that just because each time we observe a comet, we can learn more lessons about the denizens or creatures that inhabit our celestial neighborhood. And there are some that live way out on the fringes of the suburbs, like this comet here, and there's some that live near the inner city. And the inner city being, within, say, the orbit of the planets, especially Jupiter. And then there are some that come from a foreign country altogether, like 3I Atlas. And we don't really speak their language at all yet, but now we've got an opportunity to learn. And I expect that we're going to see more interstellar visitors in the coming years. Don't you also kind of think that?
Absolutely. Absolutely. Yeah. Because now we're actually capable of looking for them. We're going to be in a better position to actually observe. There was one estimate recently thrown out that we would have as many as 3 to 4 a year in the coming years that we would be observing. Now, that's someone spitballing, but we'll see what we see because we really don't know what we don't know. And I know that sounds trite and silly, but I think it's really important when we're interpreting the data that's coming in from 3I Atlas, from R2 SWAN, from K1 Atlas, and of course this new V1 Borisov. We're just starting to open our eyes to what's in the cosmos. You got any final thoughts?
My final thoughts are that, boy, we're like you said earlier in our discussion before the show, we really are on a threshold of a whole new level of understanding. How the cosmos works, what our part is in it, and it's exciting. It's an exciting time to be alive, and I would like to say that I don't know if there's any cover-ups here. I'm not going to go there. I'm not going to go to a conspiratorial interpretation of all of this, but I will say that I really do believe that it is time for really to open up the archives, have major disclosures of across the spectrum of things that have gone on scientifically and historically and politically and so on. I mean, we really need to stop this overclassification of data and evidence that is now becoming, in my mind, just pandemic. There's almost this neurotic or psychotic need to classify and control information. And we need to just bust that wide open and get the reality, whether it's unidentified aerial phenomena, whatever it might be. It's time to open the books and have serious across the spectrum disclosure. And that is my probably final thought. I will add I was able to find the estimated orbital period in years for highly eccentric comet Borisov, which will give you an idea. It's about 169,000 years. So that's we're not going to be seeing that guy come back anytime soon.
I'm not sure if I want to be around 169,000 years to see it come back. That's a long time.
That's a long time. I could conceive of 169 years, perhaps, because that's only slightly more than double what I've already been here, and I don't feel like my life should be half over yet. In fact, I feel like maybe I should be 10 or 15% into it. Because there's so much to learn, so much to do, so many exciting things that I want to be around for. And we just need to, people need to get their heads out of their butts. We need to, I don't like this dumbing down what Elon Musk has referred to as TikTok brain with the 7-second attention span, which I think suits the purposes of some factions out there to keep people just marginally functional in the real world without asking too many questions or thinking too critically. And, a lot of this stuff serves that purpose quite well, keeping people distracted with stuff that in the long term has completely inessential, completely irrelevant in the long term survival of life on Earth, of human civilization, and so on. So if I had any final words, that would probably be it right there. And as always, I enjoyed it. I've learned some things, and we'll be doing this again very soon. So thanks for joining me once again, John.
Glad to be here. Thank you, sir.
All right. Well, Until then.